सो फ्लाइट मैकेनिक्स क्या बोल रहा है? फ्लाइट मैकेनिक्स हमें बताता है कि यार, at any given phase of flight, how do the forces act on an aircraft? It's but obvious कि यार, अगर मैं climb कर रहा हूँ, forces will not be the same. अगर मैं descend कर रहा हूँ, forces will not be the same acting. They will not act in the same way. It will be different, right? So let's talk about equilibrium. What is equilibrium? Equilibrium means यार, मैं जैसा हूँ मैं वैसे ही रहूंगा. That is equilibrium. ना मेरे पे एक्स्ट्रा कुछ फोर्स एक्ट कर रही है, ना कुछ कम एक्ट कर रहा है. Everything is balancing everything out. There are no resultant forces whatsoever. Okay? So, an equilibrium is a state where if a body is in motion, it will tend to remain in the same form of motion with the same magnitude and the same direction. Two things: same magnitude, same direction. And if it is at rest, it will remain at rest. This is about rest, then there's about motion, then there's about rotation. Okay, we spoke about rest, then we spoke about linear motion. Now we'll talk about rotation also, rotational mechanics as well. So an object, if it is rotating with a certain rate, it will keep on rotating with a certain rate until an external force is applied. Okay, and to rotate it, you need to create a momentum. Koi doubt? So how can you maintain equilibrium? You can maintain equilibrium if you satisfy two conditions. What are the two conditions? The algebraic sum of all forces should be zero. That means, let's say I have an aircraft and all the upward forces should be balancing all the downward forces. All the forward forces should be balancing all the backward forces. If all the upward forces balance all the downward forces means good. If the upward forces are more than the downward forces, you're climbing. If the downward forces are more than the upward forces, you're descending. If the forward forces are more than the backward forces, you're accelerating. If the backward force is less than the more than the forward force, you're decelerating. Okay, the same funda is written over here. Next, the sum of the algebraic sum. When I say algebraic sum, what do I mean? I mean कि anything in the forward direction is positive, anything in the backward direction is negative. उन दोनों को ऐड कर दो, they should come to zero. Okay, that is what I mean by forward algebraic. Now, algebraic sum of moments. So basically, anything clockwise is positive, anything anti-clockwise is negative, right? So any clockwise moment is equal to any anti-clockwise moment. Is that clear? So algebraic sum of all moments is equal to 0. All nose up moments should be equal to all nose down moments. Now let's say if there are some unbalanced moments, what will happen? Do you think that the aircraft will rotate it 3 degrees per second? No. It will have an angular acceleration. मतलब वो रोटेशन करना शुरू तो करेगा, लेकिन उसकी स्पीड बढ़ती जाएगी, बढ़ती जाएगी, बढ़ती जाएगी, बढ़ती जाएगी, बढ़ती जाएगी. So that's angular acceleration. The rotation speed will keep on increasing. Is that clear? That so what you need is equilibrium. We are going to study 4 phases of flight: straight and level, climb, descent, and turn. An extra thing that we are going to study is asymmetric thrust and flight with asymmetric thrust. Clear? So these are the conditions in which we will study about how do the forces act in an aircraft. Because only if you understand how do the forces act in an aircraft, you'll be able to succeed as a good pilot. Okay, let's start with the basics. Straight and level flight. In simple straight and level flight, we have an aircraft. Where does the weight act from, Piyush?
Center of
Where does
gravity,
the lift act from?
center of
Where
pressure,
does the drag act from?
behind the aircraft.
From. So आपने point बताना था. But there's no such point that we have studied, so I cannot hold you here. Right? Now, हम लोग जनरली सोचते हैं यार, वेट ऐसे, लिफ्ट ऐसे, ड्रैग ऐसे, थ्रस्ट ऐसे. Can anyone tell me what is the ratio? Let's say if I have 12 units of lift, what will approximately be the amount of thrust?
आपने बोला all forces should be zero. तो
No,
वे
मैंने ये नहीं बोला. Read it again. Okay, no issues. Read it again. Think about L by D ratio.
देखो L/D रेशियो आपने बोला हिंट दे से आपने उसको लिखा
लेस होगा, यस. एक सेस्ना के लिए पकड़ो कितना होगा. 1. 12:1. एक कोई भी ट्रेनी एयरक्राफ्ट का रेशियो 12:1, क्लोज टू. लेस होगा, ऑफ कोर्स लेस होगा. So what is the force acting like? The net force in the forward direction is acting like this, correct? There's more of lift, less of thrust in terms of magnitude. अच्छा एक बात बताओ, अभी तुम टेक ऑफ थ्रस्ट डालते हो, ठीक है, तुम एक्सेलरेट करते हो, टेक ऑफ करते हो, फिर यहाँ पे आके लेवल ऑफ कर देते हो, हाँ या ना? कर देते हो. मेरा क्वेश्चन तुम लोगों से ये है कि तुम लोग यहाँ पे आके लेवल ऑफ कर देते हो, ठीक है, चलो अब स्ट्रेट एंड लेफ्ट. अब मान लो तुम लोगों को, तुम 80 नॉट की स्पीड पे, अब तुमको 100 नॉट्स पे क्रूज करना है, क्या करोगे?
इंक्रीज पावर
ठीक है, चलो तुमने पावर बढ़ाया, तो तुम्हारा थ्रस्ट का वेक्टर ऐसा है, तुम्हारा ड्रैग का वेक्टर ऐसा है, अब क्या होगा?
पावर बढ़ाया है तो थ्रस्ट और
थ्रस्ट का
बढ़ा
वेक्टर बढ़ गया, थ्रस्ट का वेक्टर बढ़ गया, ड्रैग का वेक्टर करना.
हाँ और लिफ्ट का भी चेंज होगा ना क्योंकि
लिफ्ट छोड़, पहले ये बता होगा क्या जहाज को भी. लिफ्ट कैसे चेंज होगा बता.
एज इन लाइक अगर सेम एंगल ऑफ अटैक रखते
थ्रस्ट
तो
बढ़ाया,
सेम एंगल ऑफ अटैक रखते जब बोल रहा हूँ मैं बट
वो छोड़ना, तूने थ्रस्ट बढ़ाया, तू उसके बाद क्या होगा?
स्पीड 100 पहुंची
बिल्कुल, चलो 100 पहुंच गई. उसके बाद चल, अभी स्पीड 100 पहुंच गई, अब क्या कर, अब जब स्पीड 100 पहुंच रही है तो ड्रैग का क्या होगा?
ड्रैग भी इंक्रीज होएगा
Exactly. So when your speed is going higher, the drag is also increasing in proportion to it. Till the time.
हम लोग वापस इक्विलिब्रियम स्टेट में नहीं आ जाते जब
Exactly. Exactly. Is that clear to everyone? Is that clear to everyone? इसका एक डायग्राम भी था जो मैं आप लोगों को सिखाना चाहता था. Where did the diagram go?
रेटिंग 5
Okay, let's continue. So in straight and level flight, let's take an aircraft. So let's say we have an aircraft. Here, the weight does not really act from the center of the aircraft, it acts from the center of gravity of the aircraft. Parad, what is the center of gravity of the aircraft? Give me one definition.
A point through which weight acts.
Okay, Piyush, tell me more about the center of gravity. 1 point more.
center of gravity is a point where the forces applied on it is parallel to the gravity
अच्छा, अदर कहीं और से पैरेलल टू ग्रेविटी नहीं होता?
like uh, it's a denoting point. It's not a particular point on the aircraft. Everything on an aircraft waits, but for denotation we make a point which is called center of gravity.
Okay. और क्या होता है? How else can I describe the center of gravity to anyone?
Mass is uniformly distributed.
Yes, absolutely correct, Farad. CG is a point about which the mass is uniformly distributed. And anything else? All axes intersect at this point. The aircraft rotates about this point. है ना? So that is the center of gravity, and weight acts through this point. And now lift does not necessarily act from the center of gravity. Lift acts from a point known as the center of pressure, and we are all aware about that. Otherwise, you wouldn't be sitting here. Okay. So lift acts from behind the center of gravity. This will create a nose down pitching moment most of the times. We always have like to have an aircraft which is, has the CG forward. Now we have drag, we have thrust. Now most of the times the drag and the thrust line will also create some form of turning moment. Yes. Along with the lift की वजह से turning moment. So all in all, the aircraft will have a turning moment. 90% of the time, these aircrafts have a nose down turning moment because thrust and drag are relatively smaller forces when it comes to lift. Right? Lift force is mostly dominant. Now let us understand that this upward force is creating a turning moment. This lift is creating a certain turning moment. Now this turning moment also needs to be balanced. अभी तक हम लोगों को मान दो लिफ्ट सपोर्ट्स वेट थ्रस्ट सपोर्ट्स ड्रैग ठीक है but now that would be good when you were only thinking about the forces in the system but here we also have to think about the turning moments and because you're thinking about turning moments मेरे को थोड़ी सी टेल फोर्स चाहिए होगी क्योंकि मैं नोज डाउन टेंडेंसी को काउंटर करना चाहता हूँ इफ आई हैव अ डाउन फोर्स ऑन द टेल प्लेन only then I will be able to stop the turning movement. But because of this, now see what has happened again. The total amount of downward forces has increased. So because you have a tail down force, that is apparently acting as the weight of the aircraft. Okay, an aerodynamic weight of the aircraft. Because of which you have to instead of producing this much, you have to produce slightly more lift and find somewhat like a sweet spot. Okay. Sure. So because of this, now let's come to upward and downward forces. Lift is equals to weight plus tail force. So tail force, basically all downward forces are in this section, all upward forces are in this section. Now let's say you have an aircraft. Now let's say you have an aircraft where the aircraft's center of gravity is behind the center of pressure. Okay, the center of gravity instead of acting from this point, it is acting from this point. So the wing is creating a nose up moment. And to counter this, at the tail, you should have again a nose up moment only. Right? So in that case, lift is supported by tail force, which is an up force, not a down force. Huh? In that case, lift plus tail plane force will be equal to weight. In that case, you'll need to produce a lesser amount of lift. Is that clear? ओके तो फंडा ये है अब कि हमें ये चीजें यहाँ तक आती हैं ठीक है now let's talk about acceleration and deceleration because that is the only thing that we do in straight and level flight. You don't do anything else in straight level flight. Okay, let's see about acceleration and deceleration. Now to accelerate आप thrust बढ़ाओगे. Correct? Let's have a look at the thrust and drag. So on the left side you have the thrust and drag axis, right, Piyush? In the thrust and drag axis, why do you call it thrust and drag? Are they two different things? Yes, they're two different things, but they are the same force technically. Okay, why do I say it's the same force? Because thrust drag is equal to thrust required. Correct? Drag is only equal to thrust required. Let's continue. Did we study speed stability? You've studied speed stability, right? VMD के नीचे
पढ़ाया था।
पढ़ाया हुआ okay great. So अब मान लो let's say you are stabilized on this particular point A. What does that mean? That means that you're producing T1 amount of thrust. Your engine is producing T1 amount of thrust. And you are stabilized at A. Let's say you increase your thrust setting at B. So now you are still at point A, but the thrust that is available to me that is little bit more, right? The thrust that is available to me is little bit more. Now because of this, A to B जा रहे हो तुम, क्या होगा? तुम एक्सेलरेट करोगे. जब तुम एक्सेलरेट कर रहे हो तुम्हारी ड्रैग भी बढ़ती जाएगी until the time you reach point B. Okay, until the time you reach point B, and then you will get stabilized here. Similarly, when you're decelerating, तुम इधर से B पे स्टेबलाइज हो, तुम ये कम कर दो, क्या होगा? ड्रैग ज्यादा, थ्रस्ट कम है, ऑटोमेटिक तुम यहाँ से यहाँ पे आ जाओगे, यहाँ पे आके स्टेबल हो जाओगे. That is what happens in straight and level flight. Okay, same thing is written here. Any doubts? No? Do you want to take some time to absorb it and write it down? Okay, make short notes, make short crisp notes, because these are made notes. अपने लैंग्वेज में कुछ अपने नोट्स में लिखना है तो लिख लो. ओके, एंड लेट मी नो वंस डन. रेज योर हैंड्स वंस यू आर डन. यस पीयूष.
भैया जैसे हमें पता है थ्रस्ट थोड़ी बहुत नीचे से एक्ट करती है, वो बीच में से एक्ट नहीं करती.
यस
सो और ड्रैग वो एक्ट करती है बिल्कुल बीच में से. सो वो एक चेंजिंग मूवमेंट नहीं करेगा. तो स्ट्रेट एंड लेवल
बिल्कुल
फ्लाइट.
बिल्कुल. So now always remember the moment produced due to lift is more than the upward moment produced due to drag. Once देख सेकंड भाई, एक सेकंड भाई, ठीक है? I'll come back. Give me one. Make a note of this. I'll come back. हाँ भाई, तो स्ट्रेट एंड लेवल फ्लाइट में किसी को कोई डाउट है? नहीं है ना? Let's talk about climb. हाँ, Piyush had a doubt. Piyush, so yes, that is for low mounted engines. Low mounted engines will give you a nose up moment, right? And drag beats act करता है, so that is giving you a nose up moment. Is that correct? Yes. But now what you need to understand, विंग के तुम इतना सा नीचे से थ्रस्ट प्रोड्यूस कर रहे हो, ठीक है? या सीजी के तुम इतना नीचे से थ्रस्ट प्रोड्यूस कर रहे हो, और तुम सीजी के कितना पीछे से लिफ्ट प्रोड्यूस कर रहे हो? काफी पीछे.
काफी पीछे. हाँ.
काफी पीछे. और कौन सी फोर्स बड़ी है?
लिफ्ट बड़ी है, थ्रस्ट से तो काफी बड़ी है.
So you have a nose down moment, you have a nose up moment, but they are not in equal magnitude. They are not even close to the equaling the magnitude of the turning moment, right? So yes, your thinking is correct, but you need to understand here कि जितना nose down moment है वो बहुत ज़्यादा है. उसके कंपैरिजन में अगर आप nose up देख लिया तो इसका मतलब ये था ना वो बैलेंस कर देगा.
एक से नोज अप डाउन इसलिए बोल रही क्योंकि ग्रेविटी की वेट की से ना.
Nose down is because of lift. Nose up is because of thrust.
नोज डाउन तो इसलिए होगी ना कि स्टेबिलिटी में अपन ने पढ़ा था सीएफपी के, अगर अपना सीएफपी आगे है सीएफजी से तो
Nose down is because of lift behind CG. करेक्ट? इतना समझ आ गया सब? हाँ, बताओ अब क्या डाउट है?
ठीक है, क्लियर हो गया. बट ये थोड़ा बहुत टेल फोर्स को कंपेंसेट कर सकता है. लाइक
वही
थोड़ा
तो
बहुत
कॉम्पेंसेट करता है मेरी जान.
यही कंपेंसेट करते हैं ना.
यही कॉम्पेंसेट करता है, तभी तो आया, इसी के लिए तो आया. दैट्स व्हाट इज क्लियर. So steady climb. Now let us have a look at this diagram. Draw this diagram along with me. Draw a horizon or the horizontal, the local horizontal. Any angle with respect to climb will be calculated from the horizontal. So now from the horizontal, my aircraft is following a flight path like so. This is the flight path that my aircraft is following. This is the flight path that my aircraft is following. Okay, if my aircraft is following that flight path, that means that the relative airflow is also coming from the opposite direction. Please draw the diagram in the exact same way that I am telling you, and in the exact same sequence. Things will be much clearer this way. Okay, flight path, relative airflow. Now the angle that the flight path makes with the horizon is the climb angle. It is the climb angle. Clear? Any doubts? No doubts? Physically, over the earth, over the horizon, this is the angle at which my aircraft is climbing. Any doubts? No doubts? Sure. So now we have an aircraft. ये एयरक्राफ्ट में ये सामने थ्रस्ट प्रोड्यूस करता है, पीछे ड्रैग प्रोड्यूस करता है, नॉर्मल जितना करता है, ठीक है। एंड ये नॉर्मली जितना लिफ्ट प्रोड्यूस करता है। अब देख रहे हो ये तीनों टेढ़े हो गए हैं, ये ऐसे और ये ऐसे हो गए हैं। सो इन एनी गिवन क्लाइंब और डिसेंट ये टेढ़े हो रहेंगे, लेकिन वेट सारा एक अकेला चीज है, वो अर्थ के सेंटर से टाइड है, तो वो नीचे ही रहेगा। सो अब आई कैन हैव टू ऑप्शंस, आइदर आई कैन ब्रेक लिफ्ट इनटू टू फोर्सेस and I can break thrust into two forces and I can break drag into two forces. Instead of doing that, if हम लोग weight को ही break कर देते हैं, which is one force. Yeah. So now we weight के हम लोग components ले लेते हैं. Now the component which is perpendicular to the relative airflow and the component of weight which is parallel to the relative airflow. As you can see, weight is inclined backwards with respect to the aircraft. Okay, aircraft का normal ये है. Weight is inclined backwards with respect to the aircraft. Now W sin gamma. अब देखो W sin gamma. So this is weight. Now there will be a component of weight which is perpendicular to the flight path. Now this angle will be the same as this angle because of similarity of triangles. ये थ्योरी है, इससे मैथमेटिकली प्रूव कर सकते हो। आप ये भी देख सकते हो कि तुम्हारा एयरक्राफ्ट ऐसे तो तुम्हारा फ्लाइट पाथ ऐसे। तुम्हारा एयरक्राफ्ट ने जितना ऊपर किया नोज, उतना उसका परपेंडिकुलर भी तो उतना ऐसे हो जाएगा। जितने एंगल से तुम्हारा एयरक्राफ्ट ऐसा हुआ, उतनी एंगल से तो तुम्हारा परपेंडिकुलर भी ऐसे जाएगा, करेक्ट। So you can understand that both ways. This is gamma. Gamma denotes climb angle or the descent angle. This component, because this is the base, will be W cos gamma. This component, because it is the base of the triangle, it will be W cos gamma. This angle will be W sin gamma. Okay, W sin gamma. Quite out. Now what you can see here is that you have a certain amount of extra force towards the behind, right? This extra force is known as the backward component of weight. It is creating extra resistance. We need to counter this in our climb. Because of this, we need an extra amount of thrust so that we can counter the backward component of weight. Okay, greater the backward component, greater is the weight component, greater is the thrust. अब एक बात बताइए, weight component बड़ा कब होगा? ये weight component तब बड़ा होगा जितना तुम एंगल बढ़ाते जाओगे, उतना sin gamma भी बढ़ता जाएगा, उतना weight component भी बढ़ता जाएगा, उतना ज्यादा तुमको thrust भी चाहिए. So make sense? जितना एंगल बढ़ता है उतना ज्यादा thrust बढ़ता है. Any doubts? No doubts. अब एक काम करेंगे, अब हम लोग इसमें फॉरवर्ड कंपोनेंट, फॉरवर्ड फोर्सेस बैकवर्ड फोर्सेस को बैलेंस करेंगे, अपवर्ड फोर्सेस डाउनवर्ड फोर्सेस को बैलेंस करेंगे. अब एक काम करो, इस डायग्राम को देखो और फॉरवर्ड फोर्सेस इक्वल टू बैकवर्ड फोर्सेस का डायग्राम का इक्वेशन क्या आएगा फराद? पहले तुम्हारे पास थ्रस्ट इतनी थी, अब तुमको थोड़ी एक्स्ट्रा थ्रस्ट लग रही है, पहले से इतनी थी, अब तुमको इतनी लग रही है. चलो, सो फॉरवर्ड फोर्सेस क्या है फराद? फराद, हाउ डू यू रीड? ओके पीयूष, फॉरवर्ड फोर्सेस क्या है?
थ्रस्ट और एक्स्ट्रा थ्रस्ट जो इसने प्रोड्यूस किए.
वो टोटल इज थ्रस्ट. बैकवर्ड फोर्सेस क्या है?
ड्रैग और गामा, वेट साइन गामा.
क्या? विंड साइन
ड्रैग,
गामा.
ड्रैग एंड वेट साइन गामा. वेट इनटू साइन
ड्रैग
गामा.
है और प्लस वेट साइन गामा, ठीक है. सो क्या मैं कह सकता हूं दैट माय थ्रस्ट शुड बी इक्वल टू ड्रैग प्लस वेट साइन गामा? दिस गिव्स अस इक्वेशन 1. दिस आल्सो शोस अस दैट द थ्रस्ट used to earlier equal to drag in straight angle flight, but now it has to support this as well. Okay, Now what we do is we do some amount of interpolation. We take this equation and we play around with it. Before we do that, we will talk about the upward and downward forces. Shrishti, the upward forces,
Left.
what is the downward force relative to the aircraft?
Um, W cos gamma.
W cos gamma, that is absolutely correct. So can we say that lift is equals to W cos gamma? Right. Now we will again play around with this equation. This equation number one will give us a few things. The equation number two will give us a few things. Let's see what does it give us. W cos gamma, that means L by W is cos gamma. And that means L by W is load factor. Load factor is equals to cos gamma. Is that correct? Now the funda here is the load factor less than 1 in a climb?
जाएगा
Diagram.
क्या?
कहाँ डायग्राम देखो, इक्वेशन देखो, लिफ्ट में और वेट में ज्यादा कौन सा, वेट है या लिफ्ट है?
फिर तो कॉन्ट्राडिक्टरी हो गया ना ये.
बाबा लिफ्ट ज्यादा है या वेट ज्यादा है? I can't hear you, buddy.
इस इक्वेशन में वेट ज्यादा होगा ना.
वेट ज्यादा है. You agree with me, right? लिफ्ट कम है, वेट ज्यादा है. So what does this?
हो गया था थोड़ा सा.
कोई बात नहीं. So इस equation में, as you can see, we got this equation from the above diagram. In this equation, you can see upward forces equals to downward forces. Upward forces was lift for R, downward force was W cos gamma. So what we did, we played around with the equation. W को side लेके गए, L by W is cos gamma. L by W क्या होता है? Load factor होता है. So load factor is equals to cos gamma. In this particular equation, load factor is less than 1 or more than 1? बताओ.
मैं बोलूँ क्या?
हाँ बताओ.
कॉस की वैल्यू कभी भी 1 से ज्यादा नहीं हो सकती, लेस देन 1 होगी या 1.
Exactly. So it has to be less than 1. So in a climb, in a steady climb, if we simply consider the equation, load factor is less than 1. And lift is less than weight. In a climb, lift is less than weight. What? Lift कम है climb में. What? Straight and level में तुम कम ज़्यादा lift प्रोड्यूस करो climb से. Yes, that's correct. Because when you climb, आप lift बढ़ाते हो या thrust बढ़ाते हो? तो thrust है ना काम करने वाला फंडा. So an aircraft climbs because of the extra thrust, not because of the extra lift. तुम क्रूज करते हो 100 नॉट की स्पीड पे, क्लाइम करते हो 80 नॉट की स्पीड पे, तो तुम स्पीड भी तो कम कर रखे हो क्लाइम में. तो तुम बोल ही नहीं सकते कि हाँ स्पीड बढ़ी है तो लिफ्ट बढ़ रही है. नो, यू आर प्रोड्यूसिंग द मोर अमाउंट ऑफ लिफ्ट इन अ straight and level flight than in climb. Yes, Shrishti.
Just wanted to ask, how did you find out that the weight is greater than the lift?
Okay. Firstly, you look at this diagram. Lift over here, is lift supporting the full weight? He is only supporting a component of the weight. So lift is less because he's only has to support a component of the weight. Is that correct? What happened to your finger?
That's a small infection.
Finger में.
It's around the nail.
Okay. कोई डाउट कि वेट कम कैसे, वेट ज्यादा कैसे, लिफ्ट कम कैसे? Second thing mentioned by Piyush was cos gamma. Gamma is an angle. It's an acute angle. That's not zero. It's more than zero. Is that correct? So any cos value which is more than zero, can it ever be more than 1? Or can it ever be equal to 1? No, it has to be less than 1. So if cos gamma is less than 1, that means this fraction is also less than 1. That means lift is less than the weight. So you can find it mathematically. You can also understand it via the diagram. Going to the second equation. Forward forces thrust. Parath, backward forces drag and W sine gamma. So two forces, drag and W sine gamma equals to thrust. This is the second equation. Let's see. Drag को लेके गए इधर, thrust minus drag आ गया. इस चीज को हम लोग क्या बोलते हैं? Excess thrust. As you can very clearly see, my W sine gamma is a function of excess thrust. Okay. Or we can also take the weight and put it here, and we will get sine gamma is equals to thrust minus drag divided by weight. What does this tell you? This tells you that my sine gamma. अच्छा, अब देखो मैंने एक इक्वेशन यहाँ पे लिखी है, साइन गामा इज इक्वल्स टू गामा. ये मैंने क्यों लिखा है साइन गामा इक्वल्स टू गामा? मैंने इसीलिए लिखा बिकॉज एट लो एंगल्स या बेसिकली प्रोपोर्शनल. इसको आप अभी के लिए प्रोपोर्शनल डाल दो, इतना दिमाग खराब करने की जरूरत नहीं है. सो साइन गामा विच इज प्रोपोर्शनल टू गामा, साइन गामा दैट इज प्रोपोर्शनल टू गामा. साइन देख, बेसिकली साइन गामा बढ़ेगा तो मतलब गामा भी बढ़ ही रहा है, तभी साइन गामा बढ़ेगा, है ना. अगर ये वैल्यू बढ़ेगी, अगर ये वैल्यू बढ़ेगी तो ये वैल्यू बढ़ेगी. ये वैल्यू कब बढ़ सकती है? वैल्यू तभी वैल्यू बढ़ेगी जब गामा बढ़ेगा, है ना. सो बेसिकली इफ आई हैव मोर एक्सेस थ्रस्ट, my angle of climb can also be higher, you know. But if I have more weight, my angle of climb will not be that high. So what does this tell me? This tells me that my climb angle is directly proportional to my excess thrust. Thrust minus drag is my excess thrust, and climb angle is also inversely proportional to weight. Any doubts?
सर ये आपने क्लाइंब एंगल कैसे क्लाइमेबल, ठीक है समझिए. वेट हो गया क्लियर, कुछ हो गया.
Okay. कोई डाउट नहीं? Do you want to take a minute? Do you want a minute? Yes or no? Okay. So now we can climb in two ways. We can climb in two ways. Let me show you the two ways. We have on the left the y-axis as an altitude axis. And we have an altitude A and we have an altitude B. We're climbing from altitude A to altitude B. We can climb in two ways. The motive is to reach altitude B. Okay? I can climb at a lower speed, I can climb at a higher speed. Let's call the lower speed Vx and let's call the higher speed Vy. Okay, now when I climb at a lower speed, I do not care about the lift drag ratio or drag or excess thrust or anything. The only reason why I'm climbing at a lower speed is because I don't want to cover more horizontal distance. I want to convert all of my power. I want to convert all of my forward thing. I don't want any forward thing. I want my only upward thing. So how will I get forward? How will I get less speed? By pitching up, by having a high climb attitude, right? But because I'm climbing at a very high climb altitude, my forward speed will be less, but my drag will also be higher. So this is one form of climb. This is known as when you climb at Vx, you're going from altitude A to altitude B. It is seen that when you do this, it takes you 4 minutes. Now, they thought, let's increase the speed a little bit and climb. What to increase the speed? Again, what you have to do? You will climb at full power only. You will lower the nose slightly. You will lower the nose slightly. What is going to happen? Now you're going to climb like this. So this is a steeper climb. This is a shallower climb. Why steep and why shallow? Look at this. This is an angle which is steep. This is an angle which is shallow. No doubts. So climbing like this, yes, it gave you a shallower climb, but the fun part was it took you to that altitude in lesser amount of time, 3 minutes. So again, I repeat, we have two ways by which we can climb. We can climb at Vx. In this we will not cover much horizontal distance because we have a nose attitude full up. We are getting much more drag, but we are getting less forward speed because you are getting less forward speed, and you will be able to climb at a steeper angle, but you will not be able to climb fast. Drag is higher, you will not be able to climb fast. Or you can climb shallower. Here you will be climbing at a higher speed, but the angle will be very less. But because drag will also be less and speed will also be higher, less drag, high speed, both of them are good for climb. Ankit, everything okay? One second. Ankit, everything okay? क्या हुआ? ठीक है? Think of it like a car. Car has to climb here, car has to climb here. यहाँ पे साला तुमको बहुत टाइम लगेगा चढ़ने में, लेकिन ज़्यादा हॉरिजॉन्टल डिस्टेंस नहीं कर पाएंगे. यहाँ पे साला तुम 5th गियर पे 4th गियर में तुम हिल क्लाइंब कर रहा है तो जल्दी क्लाइंब कर लेगा, बट at the expense of a shallower climb. This form of climb is known as a max angle of climb or a max climb gradient. वाला climb. This climb is known as a max rate of climb. Okay, this is a function of distance. This is a function of time. Let's say. So in max angle of climb, our motive is to have the climb angle the greatest. Correct, as the name suggests. Now climb angle is in direct proportion to excess thrust. The only thing that it depends is excess thrust. कोई doubt? On the other hand, max rate of climb. The rate of climb is not a function of thrust. It's a function of power. It's a function of power. And what is power? Okay, you don't call it power, you call it power. Power is an incorrect way of saying it. So what is power? Power is thrust multiplied by TAS. So अब thrust तो तुम यहाँ पे भी max रख रहे हो, thrust तो तुम यहाँ पे भी max रख रहे हो, तो ये आपको बेटर रेट ऑफ क्लाइंब क्यों दे रहा है? ये आपको बेटर रेट ऑफ क्लाइंब इसलिए दे रहा है क्योंकि यहाँ पे आपकी TAS हाई है. ओके, let's talk about this first. Max angle of climb. This, as the name says, it's a distance function. It says that's the max altitude gained in the least horizontal distance. मतलब मेरे को यहाँ कम जाना है, ऊपर ज़्यादा जाना है. This angle has to be the highest. Okay? So हम लोग यूज कौन सा करते हैं यार? Now depends in the situation. Let's say I get a GPWS terrain warning. Whoop whoop pull up. Whoop whoop pull up. What angle? What speed will you climb at? You will climb at a speed which will not take you much forward. You will and it take you more higher, right? So it is good for obstacle clearance. So always when you want to remain clear of obstacles, or you are flying, let's say you're flying into Silchar, you're flying into Imphal, you need to fly at a speed which will give you the max angle of climb. Yeah? No doubts? Okay? And this speed at which the excess thrust is maximum is known as the Vx. Let us understand this on a graph. This is the thrust versus indicated airspeed graph, or the drag versus indicated airspeed graph. On this axis, we have force. You can call it thrust or you can call it drag. On this axis, we have the indicated airspeed. Now, what you can understand by this graph, you see the drag line. This is the total drag curve, and we've always seen it. Now, you also know that over here you have the minimum drag, and this minimum drag over here is here. Okay. Now, let us look at thrust. Thrust available is like this. So, what does this teach you? This teaches you this is तुम्हारी speed बढ़ती जाती है, तुम्हारी thrust available कम होती जाती है. Okay. My thrust available come what because why what is thrust? Thrust is a function of the acceleration given to the mass of air. अब तुम अगर 300 की स्पीड पे चल रहे हो, पहले तुम क्या कर रहे थे? तुम 0 से 400, हवा 0 की थी, तुम उसको 400 पे एक्सेलरेट करते, लेकिन हाई स्पीड पे तुम तो 200 से आगे जा रहे हो और तुम उसको 400 खींच रहे हो. तो एक्सेलरेशन तो 200 ही हुआ ना, पहले 400 का एक्सेलरेशन था, अभी तुम्हारा एक्सेलरेशन तो 200 का ही है, तो थ्रस्ट कम हो जाती है with increase in speed. So thrust available decreases. Now what we do is we find out the point where the difference between the thrust available and the thrust required is the maximum. And then we plot it, and the speed that we get is the Vx. Because at this speed, I am getting the max excess thrust. And if I get the max excess thrust, my climb angle will also be the highest. Is that clear? Now talking about max rate of climb. Max rate of climb is a function of excess power, and this is a function of time. Maximum altitude gain in the least amount of time. This is good for traffic separation. Example, let's say ATC tells you, or you get a TCAS warning. Whoop, whoop, climb now, climb now. Basically, an intruder has come inside and there is a potential collision threat. That is why the TCAS system is giving you a warning. So the funda is ki bro, you want to get out of his altitude or his level as soon as you can. It's a function of time. Because TCAS gives you warnings based on time. So you want to get out of his altitude as quickly as you can. As quickly as you can. ATC tells you expedite climb passing level 80. Expedite, function of time. Clear? No doubts, right? Okay. So at what speed does this happen? This happens at a speed known as Vy, because we choose Vy as a speed at which the excess power is at the maximum. Only when the excess power is at the maximum, I will get the max rate of climb. So again, in this graph, I am shown power versus indicated airspeed, or power versus indicated airspeed. If you have read your Oxford, in lift chapter itself, you have the minimum power curve or the power curve. How do we make the power curve? How do we make the power curve? We take this curve. So what is this? This is basically drag, right? So drag की जगह मैं इसको thrust available भी बोल सकता, thrust required भी बोल सकता हूँ, thrust required curve. अब at this indicated airspeed, what is my drag? What is my... So basically I multiply this indicated airspeed with this amount of drag. I'll get a power value. I'll multiply this speed with this amount of drag. I'll multiply this speed with this amount of drag, this speed with this amount of drag. So at every given point, I will get a value of power. At every point, I will get a value of power, right? And I plotted it against a graph. So basically, at this indicated airspeed, this is the amount of power that I'm producing. At this indicated airspeed, this is the amount of power that I require. Not producing, require. Okay, just like you require drag, this is also a value of how much power you require, because power and drag are different. So you require this much amount of drag. So at low indicated airspeeds, you require higher power. And then somewhere about the point at which you require the least amount of power, you have this speed known as VMP, also known as minimum power speed. We'll discuss about this a little later. And after that minimum power speed, your power required keeps on increasing exponentially, more than the drag increase as well. Okay. On the other hand, the power that is available to us increases with increase in speed. Now, this is in contrast to thrust. Why is this so? Thrust decreases with increase in speed, but power increases with increase in speed. Why? Because power का function ही क्या है? Power का formula ही क्या है? Power is equals to thrust multiplied by TAS. है ना? तो TAS बढ़ेगी तो power भी तो बढ़ेगी. ठीक है जी? So this is what the power curve looks like. Again, just like we did it last time, we find a point where the excess power is maximum. And the speed at which that happens is zero. 99% of the time, mostly 100% of the time, Vy is the speed which is more than Vx. Okay? Any doubts? Yes, please.
भैया आपने पीछे बोला था कि हमने वो फंक्शन देखा था लिफ्ट बाय वेट इज इक्वल टू गामा
Sorry?
लिफ्ट बाय वेट इज इक्वल टू cos थीटा और लिफ्ट बाय वेट होता है अपना
Cos gamma.
cos गामा सॉरी तो लिफ्ट बाय वेट होता है अपना लोड फैक्टर क्लाइंब में आपने क्वेश्चन पूछा था कि कब से होने लगा लोड फैक्टर तो 1 से ज्यादा आएगा फिर वो कॉन्ट्राडिक्टरी नहीं हो गया
कब बोला टाइम में लोड फैक्टर 1 से ज्यादा होगा?
नहीं नहीं मैंने बोला था कि क्लाइंब में कि लोड फैक्टर अपना 1 से ज्यादा होते हैं ना
कौन बोला? आप बोला, मैं तो नहीं बोला.
हाँ मैं बोला था
तो गलत बोला ना?
ऐसा नहीं होता क्या फिर फिर
आप ये आपके दिमाग में चल रहा है कि मैं ये कर रहा हूँ तो मेरे को हाई जी फोर्सेस फील हो रहे हैं, तो लोड फैक्टर बढ़ ही रहा है ना.
हम्म
दैट इज व्हाट यू आर थिंकिंग.
हम्म
आपके दिमाग में वो चीज आ रही है.
हाँ
But that is when you are, this is why I told you, Piyush, this is a steady climb. That means आपने वो जूम कर चुके हो और वो जूम कर चुके हो और आप बैठ के आप इधर स्टेबलाइज हो चुके हो. यू आर इन द ट्रिम्ड स्टेट.
स्टडी वो कीवर्ड आ गया यहाँ पे
एवरीथिंग हैज अ मीनिंग इन टेंशन.
ठीक है
Okay, of course, you're right, Piyush. If I do this on my control surface, I will feel G forces. You are right, and I also feel G forces, right? Everyone does. But this is a case of steady climb.
समझ गया
Any doubts?
नहीं
Good stuff, right? Never understood Vx and Vy. Will you ever forget this now? Sure. Make a note of it. Let's have a short 5-minute break. कैसा लग रहा है फ्लाइट मैकेनिक्स? मजा आ रहा है? Interesting. Sure. So let's talk about the factors that affect the climb performance of an aircraft. As discussed, weight is inversely proportional to any form of performance, right? So climb gradient भी कम होगा, angle of climb भी कम होगा. So what is climb gradient? Good question ना? What is climb gradient? आप लोगों ने यहाँ पे पूछा नहीं, मेरे से डाउट नहीं पूछा कि भैया climb gradient क्या होता है यहाँ पे? What is this climb gradient? Yes, Piyush, tell me.
तुम लोगों ने कितना हॉरिजॉन्टल डिस्टेंस कवर किया इन वर्टिकल डिस्टेंस लाइक
ठीक है.
अगर 10% दिखा रहे तो मतलब तुम लोगों ने 10 फीट ऐसे किया और 1 ऐसे किया
एक क्वेश्चन पूछे. आप एक रनवे से टेक ऑफ कर रहे हो and you are following a SID. You are following a SID. कोई डाउट है किसी को अभी तक? नहीं ना? The SID requires a 7% climb gradient. Okay? You need to tell me two things. First, you need to tell me angle of climb, and if my ground speed is 200 knots, कि अगर मेरी ग्राउंड स्पीड है तो मेरा रेट ऑफ क्लाइंब कितना होना चाहिए?
मेरे को एंगल ऑफ क्लाइंब और रेट ऑफ क्लाइंब बताना है विद 200 नोट्स ना.
यस. Let me know once you've done finding the answer. कितना आ रहा है आंसर? 4.2 आया सबका? कैसे आया? आप लोगों को ज़्यादा टाइम लगा? क्या यही सेम फंडे से किया? What does 7% mean? 7% means you'll go 7 up, 100 forward. राइट. अब एंगल देखना है. एंगल के लिए तुमको कोई यूनिट कन्वर्जन वगैरह तो करना होता है नहीं, है ना? बस डिस्टेंस ऑफ बाय डिस्टेंस थीटा चाहिए, एंगल चाहिए. डिस्टेंस ऑफ बाय डिस्टेंस 1 into 60 करो, 4.2 आंसर आएगा. ठीक है. नाउ टेल मी रेट ऑफ क्लाइंब.
आ गया.
बताओ क्या कैसे किया, पहले ये बताओ.
इसमें मैंने वही लगा दिया, रेट ऑफ डिसेंट वाला 5/3 इंटू ग्राउंड स्लोप.
एग्जैक्टली. रेट ऑफ डिसेंट का उल्टा कर लोगे चल जाएगा. कैसे होगा? सो दैट नाउ यू मल्टीप्लाई 5 मल्टीप्लाइड बाय 200 करोगे तो आपको 1000 आ जाएगा. बट दैट इज फॉर अ 3 डिग्री ग्लाइड स्लोप. तो यूनिटरी मेथड करेंगे, है ना? 3 डिग्री ग्लाइड स्लोप के लिए यूनिटरी मेथड करेंगे तो डिवाइडेड बाय 3 मल्टीप्लाइड बाय 4.2. आपको यही चीज ऑक्सफोर्ड में कैसे बोली गई थी? थीटा डिवाइडेड बाय 3 into 5 into ग्राउंड स्पीड. करेक्ट. ऑक्सफोर्ड में ऐसे ही सिखाया जाता है सृष्टि. बट अगर देखा जाए तो इतना सिंपल है. जो भी ग्राउंड स्पीड है उसका 5 टाइम्स हमारा रेट ऑफ क्लाइंब या डिसेंट होगा. लेकिन वो 3 डिग्रीज के लिए, तो 1 डिग्री के लिए बाय 3, 4.2 डिग्रीज के लिए मल्टीप्लाइड बाय 4.2. राइट. गुड. सो व्हाट एम आई गोइंग टू डू विद दिस? इसको काट सकता हूँ मैं? हाँ काट सकता हूँ. क्या आएगा? 8 आंसर आएगा. नहीं 8 नहीं आएगा. क्या आएगा?
1.4 हो गया ना.
1.4. अब 1.4 लेने की जरूरत नहीं है. 0 हटा दो, 14 कर दो इसको, है ना? अब और ज्यादा सोचने की जरूरत नहीं. 14 और 5 कितना होता है? 70 होता है. हटा दो इसको, 70 लिख दो. 70 और 20 कितना होता है? 1400 होता है. 1400 फीट पर मिनट. समझे? चलो गुड. So please have a look at this. Angle of climb and climb gradient is the same. Okay, it's the same. Angle बढ़ेगा, gradient बढ़ेगा. Angle और climb gradient में इतना सिंपल सा फंडा है कि लेट्स से अगर तुम्हारा climb gradient 7% है ना, तो 7/100. अगर सीधा सीधा तुम इसका tan निकालोगे ना एंगल ऑफ क्लाइंब का, तो तुमको ग्रेडियंट मिल जाएगा. What is gradient? Nothing but tangent. What is it? Perpendicular by base. Okay. Let's have a look at this. So weight increases. Always remember, whenever weight increases, all speeds will increase. All speeds will increase, no matter what. Okay. Now let's talk about altitude. Whenever your altitude increases, what happens to your angle of climb and rate of climb? It decreases. I have a question. When your altitude increases, your drag decreases, but your thrust also decreases. So You call it an increase in altitude, decrease in pressure, decrease in density, increase in temperature, same shit. Okay, same shit. So instead of like three things, I'm making you write it in one sentence itself. Okay, now let's, what will happen when you extend flaps? Farad, do you think your angle of climb will increase or decrease? Flaps बढ़ गए तो लिफ्ट ज़्यादा मिलनी चाहिए तो angle of climb.
Increase.
Very good. Look at the answer. Why so? Angle of climb depends on Farad. Angle of climb. Farad.
Thrust.
Farad. Depends
Thrust.
on
Thrust.
no. Excess thrust.
Excess thrust. Right.
Excess thrust. Excess means if Farad barbar exit. Okay, whatever be the case. What does excess mean? Excess means ड्रैग को केटर कर लिया. फराद, एक्सेस मींस ड्रैग को के लिए केटर कर लिया, बाकी कितना बचा? So now tell me something. If I extend my flaps, what will happen to my drag? Farad, if I extend my flaps, what will happen to my drag?
Drag will also increase.
Absolutely. So excess thrust will
Excess thrust should increase.
ड्रैग बढ़ रहा है. फराद, ड्रैग बढ़ रहा है, एक्सेस thrust क्या होगा? सिंपल है,
कम जाएगा.
कम जाएगा ना. तो एंगल ऑफ क्लाइंब क्या होगा?
Angle of climb कमेगा.
कमेगा ना. सिंपल है. कोई डाउट? नो डाउट. Okay, so I think we are done with flaps here. Let's talk about headwind or tailwind. Do you think? Okay, think about it. Headwind आ रही है, what will happen to your angle of climb? Increase. Who will think increase? Good. Ankit, Farad, what do you think? नेक्स्ट में जाता है, मैं बताऊँ. तो देखो फंडा क्या होता है. लेट्स से तुम्हारा एयरक्राफ्ट है एंड स्टिल एयर में देखो वो इतना आगे जाता है एंड उसकी रेट ऑफ क्लाइंब तो उतनी, लेट्स से मान लो 300 फीट पर मिनट इतनी है. So this is the angle at which he climbs, correct? But now let's say you have headwinds. So when you are in nil winds, your TAS was equals to your ground speed. TAS ground speed same. But now angle of climb is taken from TAS or from ground speed? Ground speed, right? तुम physically कितना distance आगे गए? So अब तुम physically ही अगर कम distance आगे गए हो because of that 20 knot headwind, so your this thing is over here. So this is my angle. समझे? So because of you have headwind, you're going lesser distance forward. Because you're going lesser distance forward, what will happen to the angle? But the fun part to notice here is, will this change? Will the rate of climb change? No. Why? Any horizontal change in winds has nothing to do with any vertical change in winds. Okay? हॉरिजॉन्टल चीजें वर्टिकल चीजों को अफेक्ट नहीं करेंगी. एंगल्स को अफेक्ट कर सकती है, वर्टिकल चीजों को अफेक्ट नहीं करेंगी. इज दैट क्लियर? सिमिलरली टेलविंड्स.
वरना ऐसे भी सोच सकते हैं ना कि थ्रस्ट रिक्वायर्ड थ्रस्ट अवेलेबल में विंड्स का इफेक्ट नहीं पड़ेगा, तो वहां पे अपनी Vx सेम टू सेम रहेगी, तो अपना डिस्टेंस कवर्ड वर्टिकली
rate has to do with power. So we won't call it, because if you're thinking about excess thrust, then angle of climb should also not change, but it's changing. ठीक है भाई? So tailwind also no effects because it does not have any effect on rate of climb. Vx Vy will remain the same. कोई doubt? No doubt, huh? Sure, good. Now let us come to steady descent. Do you guys want to take a while and note all of this down, or you have already noted it down? Who needs 1 or 2 minutes? Tell me. Okay, okay. Take your time. Let me know once done. I'm here. चलो resume करते हैं. Let's talk about descent. Steady descent. Piyush, what does steady mean?
सेम चीज मोशन में रहना.
Steady means you have established in descent and you are in a trimmed state and you have left the aircraft. Okay, you are not in the process of coming into the descent. You have come into the descent. Speed has stabilized, all forces have stabilized, you have trimmed the aircraft, and now the aircraft is going. That is steady descent. Clear? Let us have a look at the diagram. Again, we will have the flight path of the aircraft. Steady descent. We have the Earth's horizontal. The aircraft is coming in a flight path like so. The angle that the flight path makes with the local horizontal is known as the angle of descent. Yes, Farad. So you have this particular angle, and this is the flight path, this is the Earth's horizontal. Now, this is the particular angle, and this is the angle of descent. This diagram, very similar to the last diagram, has to do with. Acha, you were talking about angle of descent and rate of descent, right? And angle of climb, rate of climb, Farad. A very similar concept, like exact same, but instead of climb, but in descent, we will encounter that in the descent wala part. So if you understand that, you'll be able to understand the climb one as well. It's the same concept. Okay. Now, just like the last one, we have drag acting backwards, we have thrust acting forward, we have lift acting perpendicular to the relative airflow, and we have weight acting vertically downwards. Thrust, lift, drag are mutually perpendicular. Like thrust left perpendicular, drag left perpendicular, drag balance thrust. Now, this angle again, just like the last angle, due to similarity of triangles, or you can consider कि भाई हाँ normal भी उतनी angle से change होगा जितने angle से मेरा flight path change हो रहा है. This angle is also gamma. Good morning, Piyush. And this particular force, we divided weight into two components, W cos gamma, and here we have this component of weight. Now, unlike the last diagram, weight is acting in the forward direction. Okay, which is W sine gamma. This is the forward component of weight, and this time this weight is balanced by drag. Just like last time, we will be creating two equations out of it. L is equals to W cos gamma, L by W is equals to cos gamma, and load factor is equal to cos gamma. So in a descent, load factor is less than, everyone knows this, 1, less than 1, everyone knows this. Beautiful. Do you want me to explain this? It is explained in the climb wala funda. Okay. Okay, Farad, tell me. Note down, tell me all the forward forces, Farad.
क्या बोला भैया आपने?
Tell me all the ध्यान का है मेरी जान.
कभी कभी ब्रेक हो रहा है तो.
Tell me all the forward forces.
फॉरवर्ड फोर्सेस.
ये डायग्राम देख. what forward forces, वो forces जो forward direction में ऐड करती है, forward forces.
थ्रस्ट.
And
और ये साइन गामा जो है वेट का.
पूरा पढ़ो.
वेट साइन
W sin gamma है ना, that sin gamma component of weight, correct? That is the forward component of weight. Backward forces कौन सी हैं?
ड्रैग.
Drag. So can I write down an equation which says thrust is equals to drag is equal to thrust plus W sin gamma?
राइट.
But in this equation, instead of it being T minus D, it will be D minus T. And W sin gamma will be proportional to D minus T, which is instead of excess thrust, it is excess drag. Okay. We bring weight to the bottom. That is excess drag divided by weight, which is proportional to sine gamma or my descent angle. So can I say that greater the drag, greater the descent angle, directly proportional? Yes? Okay. What about weight? Greater the weight, lesser the descent angle. Okay? कोई doubt? No doubt, right? Why lesser the descent angle? अब आप लोग सोच रहे हैं वेट तो भारी है, तो डिसेंट एंगल क्यों कम होगा?
डिसेंट एंगल मतलब शैलो अप्रोच ना, कम डिसेंट एंगल.
यस, शैलो.
अब शैलो अप्रोच आ रही है.
वेट
हाँ,
तो आपकी
लिफ्ट
शैलो अप्रोच क्यों होगी? थिंक अबाउट इट.
लिफ्ट और वेट अपना कम इक्वल होता है नॉर्मली. तो वेट ज्यादा तो लिफ्ट ज्यादा तो अपनी वेलोसिटी ज्यादा.
यस, एब्सोल्युटली करेक्ट पीयूष. वेलोसिटी पे आप आ गए, दैट्स द बेस्ट पार्ट. आई कैन डिसेंड एट वीएस whatever, बट जो मेरी मिनिमम स्पीड है, देख मैं नाक अगर ऐसे रखूंगा मेरी स्पीड ये रहेगी. ठीक है. व्हाट इज द लीस्ट डिसेंट एंगल दैट आई कैन मेन? मेरे को वीएमडी पे मिलेगा. करेक्ट. वीएमडी मिनिमम ड्रैग स्पीड पे मिलेगा. चल जो भी, इसके ऊपर हम लोग डिस्कस करेंगे. फंडा क्या है, आई विल गिव यू. सो होता क्या है, this is something that I learned when I was flying the 320 and the 321s. Okay, so 319 पे जनरली जब भी हम लोग फ्लाई करते हैं, सो वेरी स्लाइट एयरक्राफ्ट. ठीक है. 62 टन्स का एयरक्राफ्ट होता है. ठीक है. 62-64 टन्स का एयरक्राफ्ट होता है. फिर हम लोग 321 भी फ्लाई करते हैं. इट्स एन 89 टन एयरक्राफ्ट. 89 टन्स का एयरक्राफ्ट होता है. भारी एयरक्राफ्ट है भाई, भारी एयरक्राफ्ट है, क्या दिक्कत. तो हम लोगों को टॉप ऑफ डिसेंट कैलकुलेट करना होता है कि भाई इतने नॉटिकल माइल पहले अगर हम लोग डिसेंट करेंगे तो हमारा सही हो जाएगा. दैट इज व्हाट वी डू इन आवर टॉप ऑफ डिसेंट कैलकुलेशन. नाउ वी लिटरली हैव टू केटर. नाउ मैं डिसेंट कर रहा हूँ, आई एम गोइंग टू डिसेंट एट अ सर्टेन स्पीड, राइट. बट हम लोग फॉर अ 321 विच इज एन हेवियर एयरक्राफ्ट, it will have a descent angle which is shallow. Why? Because it has to maintain higher speeds, because उसका weight ज़्यादा है. समझ रहे हो? Because it has to maintain higher speed, उसका descent angle कम हो जाएगा. Clear? But that's not the point here. The point here is we can descend in two ways. Okay. Either we can have a descent which is really sharp and steep. That's called an emergency descent. Or we can have a glide. What is the difference between the two? In an emergency descent, my aim is to have the highest rate of descent. I need to come down as quickly as possible. But in a glide, I need to have the least descent angle. Climb में भी हम लोगों ने दो टाइप के डिस्कस किए थे, यहाँ पे भी हम लोग दो टाइप के डिस्कस करेंगे. Glide, we need to have the least descent angle. क्यों? What is the least descent angle का क्या फंडा? मैं क्लाइम करना चाहता हूँ कम डिस्टेंस में ज्यादा क्लाइम करना चाहता हूँ. डिसेंट में मैं कम ज्यादा डिस्टेंस में एकदम कम डिसेंट करना चाहता हूँ, या फिर कम डिसेंट में एकदम ज्यादा जाना चाहता हूँ. दैट इज व्हाट अ ग्लाइड का एम इज, राइट. सो ये एम कहीं पे काम आएगा ना हमें, इसीलिए तो हम लोग कर रहे हैं ना. इमरजेंसी डिसेंट हमें कहाँ काम आएगा? लेट्स से यू आर फ्लाइंग एट 36,000 फीट एंड यू हैव अ प्रेशराइजेशन फेलियर इन योर एयरक्राफ्ट, and you have a pressurization failure in your aircraft. Okay, what are you going to do? Establish an emergency descent. Okay, what is the first action that you do? Very good. Ankit remembers this. I had discussed this once. The first action that you do is you put on your masks, oxygen masks. Okay, because hypoxia होगा. उसके बाद तुम descent करोगे. Because time of useful consciousness is very, very less. It's in seconds. कब चाहोगे पता भी नहीं चलेगा. So that is why you need to have your masks on. कोई डाउट? नो डाउट्स. चलो लेट्स टॉक अबाउट प्रेशराइजेशन फेल. प्रेशराइजेशन फेलियर हो गया इसीलिए नीचे आ रहे हो प्रोजेक्ट. What when do you need a glide? You need a glide when you have an engine failure. Engine failure में let's come to a Cessna. Cessna is a single engine aircraft. In a single engine aircraft, let's say you're at 5,000 feet. Okay. And the landing field is far away. You will have to reach there, right? But what happens when an engine fails? Your aircraft becomes a glider. So you want to get the best glide performance. उसके बारे में स्टडीज हम लोग इसके नीचे करेंगे. That's the reason. Okay. Also, let's say when you fly a twin engine aircraft, let's say I'm flying at 36,000 feet and I'm flying an A320. तब भी मैं ग्लाइड करूंगा. लेट्स से मेरा सिंगल इंजन फेल हो गया, ऊपर हो, एक इंजन फेल हो गया, तब भी मैं ग्लाइड करूंगा. लेट्स से I have an obstacle over here. I have a big mountain and I'm flying like this. If I do not do a glide, if I establish a steady descent, I will come like this. But if I do a glide, but on a single engine, I will come like this. To give you a better obstacle clearance, you do a glide. Okay? Yes, Piyush.
Better than a glide in a twin engine. Can't we use one engine in open perform the same criteria?
Yes, you are right. You will use the engine to perform the same. But here the glide funda is कि when do you do a glide? Glide does not necessarily mean कि यार तुम इंजन है ही नहीं और तुम्हारे पास पावर है ही नहीं कि तुम जा रहे हो. ग्लाइड व्हेन इट कम्स टू आर केसेस, यहाँ तो तुम सारे इंजन गए तुम ग्लाइडर बन गए. यहाँ पे पता है हम लोग क्या करते हैं 320 में? अगर हमारे पास एक इंजन है तो हम लोग दूसरे इंजन को फुल पावर पे रखते हैं एंड हम लोग एक ऐसे तरीके से डिसेंड करते हैं कि मेरे पास एक तो थ्रस्ट भी है, ठीक है. 36,000 फीट पे मेरा एयरक्राफ्ट सस्टेन नहीं कर पाएगा. फन फैक्ट, सिंगल इंजन के साथ मेरा एयरक्राफ्ट नहीं, वो 24,000 पे आएगा, 24,000 पे स्ट्रेट लेवल आएगा, लेकिन तब तक तो वो डिसेंट करेगा ना. अनकंट्रोल्ड डिसेंट ही है. तो इससे अच्छा अब आई कैन डिसेंट इन 2 ways पीयूष. आई कैन आइदर जस्ट डिसेंट लाइक मैं एवरीडे नॉर्मली करता हूँ, or I can go to my glide speed where I will get my highest L/D ratio. Because in that way, I am instead of coming down like this, I am spending more time at a higher altitude. Right? मैं ऐसे
There
आ
are
रहा
options
हूँ.
मिलेगी
अगर
time
मैं
पे.
यहाँ पे आके मैं यहाँ पे जा रहा हूँ, मेरा फ्यूल बर्न कौन से में ज्यादा होगा? इसमें ज्यादा होगा ना. मेरा ऑब्स्टिकल सेपरेशन कम किस में होगा? इसमें कम होगा ना. It is always better to be flying higher. More TAS, less density. Okay. So let us discuss the two types of descent. The aim is discussed for both cases. Now let us see how we can achieve this aim. Whenever you want to get into an emergency descent, your main action is to maximize rate of descent. How can you do that? You want excess drag. Excess drag तुमको कैसे मिलेगा? तुमको D minus T maximum चाहिए. कैसे मिलेगा? D बढ़ा दोगे, T कम कर दोगे, यही करोगे. Closing thrust, increasing drag, and speed भी बढ़ाओगे. इसके बारे में मैं आऊंगा, स्पीड क्यों कैसे बढ़ाओगे, क्या फंडा है इसका. इंक्रीज स्पीड बाय लोअरिंग द नोज. इसमें क्या होता है इंक्रीज स्पीड बाय लोअरिंग द नोज? मतलब ये है कि ब्रो देख, अगर तेरा डिसेंट एंगल इसकी जगह ऐसा है तो तेरा W sin गामा बढ़ जाएगा. Basically, if you're not descending like this, as explained in the previous diagram, if you're doing a steeper descent, that means your W sin gamma will be higher. Is that correct? And the drag will be lesser. What does this mean? That the aircraft will accelerate in a descent. गिरेगा, बढ़ेगी उसकी स्पीड, बढ़ेगी. कब तक बढ़ेगी? जब तक ड्रैग उसको इक्वलाइज नहीं कर देगा. बेसिकली अगर मैं स्पीड बढ़ाऊंगा तो मैं कैसे बढ़ाऊंगा? नोज को नीचे करूंगा और स्पीड बढ़ाऊंगा. आई कैन आइदर पहले कैसे डिसेंड करता था, पहले ऐसे डिसेंड कर रहा था, करेक्ट. अब मैं ऐसे डिसेंड कर रहा हूँ. इमरजेंसी डिसेंट होगा, मैं कैसे डिसेंड करना चाहूंगा. डू आई वांट टू डिसेंड लाइक दिस और डू आई वांट टू डिसेंड लाइक दिस. रॉकेट की तरह नीचे जाना चाहूंगा ना मैं तो. हाँ है ना. तो basically what you'll do is you'll lower the nose and increase your airspeed because now you're lowering the nose. Descent establish कर दिया, ठीक है. And you will increase your airspeed because अगर तो यहाँ पे 250 मेंटेन करेगा डिसेंट में, तो 250 नॉट्स मेंटेन करेगा और एक रेट ऑफ डिसेंट रखेगा, तो तू ऐसे जाएगा. लेकिन अगर तू 300 मेंटेन करेगा तो भी तेरा डिसेंट एंगल तो चेंज नहीं हो रहा, तो तेरे को रेट ऑफ डिसेंट तेरा ऑटोमेटिक बढ़ जाएगा. गेटिंग इट? अंकित नहीं समझ आया? आया ना, ठीक है. So the emergency is done by doing these three things. Piyush, you have done multi-engine flying. How do you do an emergency descent in your multi?
मुझे पावर डिसेंट आ रहा था बार बार, इमरजेंसी डिसेंट तो फॉर सम रीजंस. बट इमरजेंसी डिसेंट होता है अपना फुल क्लोज थ्रॉटल, नोज डाउन, जब तक ग्राउंड पूरा दिखे ना बहुत ज्यादा, और रेफरेंस ऑल्टीट्यूड से 300 फीट 500 फीट पहले रिकवर करना शुरू करता हूँ.
Okay, good. So if you are flying an A320, what is your reference altitude?
डिपेंड करता है ना वो तो अलग अलग कि तुमने क्या सेट किया है इमरजेंसी ऑल्टीट्यूड. बट इन योर
Think
केस इट
about
विल
it.
बी 24.
Hypoxia था, तो तुम कौन से ऑल्टीट्यूड पे आना चाहोगे? 26,000?
10,000.
10,000. टेरेन 9,000 पे, फिर
Then I'll be at 20,000 feet. 19,000. 19 पे ना टेरेन?
9 पे, 9 पे.
9 में?
बट हिमालय है.
हिमालय से माउंटेनियस रीजन में 1000 फीट का
2,000.
2000 फीट का होता है.
तो 11,000. ठीक है.
11.
So you will, that is also a funda. Now what are the factors that affect this emergency descent? Does the L by D ratio affect this descent? No, it only affects the glide. Okay. In glide, we will study that the L by D ratio controls the entire glide. Okay. I'll come to this L by D ratio once again. We'll go to glide first. We'll go to factors affecting later. In a glide, we want to have the least descent angle. Okay. How can we have the least descent angle? In one, we need to have this maximum. In the other, we want to have this minimum. So basically क्या हो रखा है? In a descent, in an emergency or in a glide, thrust is 0. मतलब your entire sine gamma is dependent by drag by weight. You want to minimize this. How can you minimize this? By minimizing the drag. So at what speed will you fly?
Best flight range speed 60 knots for 152.
Which is also corresponding to your V.
MD.
Okay, so 65 knots for a Cessna was your VMD. Okay, you need to maintain drag to the minimum possible and flying at VMD. Any doubts? This is achieved by this. Sure. Now let us see what are the factors that affect the glide. We'll study about glide first and then we'll talk about emergency descent because that way we'll be able to understand things better. What are the factors affecting glide? Firstly and most importantly, the L by D ratio. What is the L by D ratio? L by D ratio, as the name suggests, is the ratio of the lift is to drag, and it is also known as the gliding ratio. Why is it known as the gliding ratio? Because let's say my L by D ratio is 12:1. That means I'm producing 12 units of lift for 1 unit of drag. That means, okay? But how does this implement us in the form of a glide? When we have an L by D ratio of 12:1, that means for every 1 unit that we go down, we'll go forward 12 units. Okay. So I want this value to be the maximum so that I can go most forward the maximum. If I go more forward maximum, my glide angle will be the least. This angle will be least. So L by D ratio हम लोग ऐसा रखते हैं, max रखते हैं ताकि मेरा glide angle सबसे कम रहे. Okay, Shashi. Easy?
Think so.
Easy? Any doubts? No doubts? Yes, Piyush, tell me.
तो हम लोग स्ट्रेट एंड में लेफ्ट एंड राइट एल बाई डी रेशियो बोलते हैं जब तो डिसेंड नहीं होता, जो कि बहुत बेकार क्वेश्चन है बट
मैं समझा नहीं एक बार, कैन यू प्लीज रिपीट योर क्वेश्चन?
in a straight and level flight we also see L by D ratios ना, but we don't descend at
Your
power
thrust is also not zero, na?
पावर नहीं होती, ठीक है समझिए.
Any doubts anyone yet? समझ गए ग्लाइडिंग रेशियो एल बाई डी रेशियो का ग्लाइडिंग रेशियो के साथ क्या लेना देना है एवरीवन? फरहाद समझ गया?
नहीं, मैं डिस्कनेक्ट हो गया था, एक बार देख रहा हूँ.
सो फंडा क्या है, अगर तुम कहते हो 12/1 का एल बाई डी रेशियो है, दैट मीन्स 12 लिफ्टों का एक ड्रैग होगा. ये तो एल बाई डी रेशियो, और इसका मतलब एक और है कि तुम 12 यूनिट आगे जाओगे और 1 यूनिट नीचे जाओगे. ओके पीयूष, सेस्ना का एल बाई डी रेशियो क्या था? अच्छा, ग्लाइडिंग रेंज क्या था? 2 नॉटिकल माइल या 15 नॉटिकल माइल? 15 नॉटिकल माइल, 1.5.
1.5 था कि अगर आप 1000 फीट पे 1.5 नॉट,
एएफएम में तो 2 था ना.
152 में तो 1.5 था भैया, 170 का तो मैंने
चलो अब एक काम करो, अगर मेरे सेस्ना के एएफएम में, लेट से पीयूष इज सेइंग सेस्ना के एएफएम में लिखा हुआ दैट माय ग्लाइडिंग रेंज इज 1.5 नॉटिकल माइल पर 1000 फीट. Find out my L by D ratio. Correct. मेरे हिसाब से 172 का जो हम लोगों ने देखा था ना, वो 2 नॉटिकल माइल्स था. A320 का तो 2:1 है. ये 2 नॉटिकल माइल्स 2000 फीट.
मुझे इसलिए याद है क्योंकि सर्किट ऑल्टीट्यूड जैसे हम मैं बोलते थे ना कि 1.5 नॉटिकल माइल का होता है, इसलिए सर्किट अगर तुम्हारा इंजन फेल होता है तुम लोग इजीली लैंड कर सकते हो.
बट दैट यू डोंट कंसिडर फॉर टर्न्स. उसमें तुम्हारे 2 टर्न्स भी तो आते हैं भाई, क्या बात कर रहे हो
हाँ,
फिर?
तो ऐसे थोड़ी ना आप कि पूरा रेक्टेंगल बनाते हैं फिर
It
आप
doesn't matter. It doesn't matter. What matters is what is written in section 5 of your POH.
चेक करूँ, मेरे पास अभी भी है.
मैं बता रहा हूँ 172 का तो 2 नॉटिकल माइल था मेरे हिसाब से. ठीक है, उसमें ग्राफ दिया रहेगा मोस्टली. तो सेस्ना में तो ग्राफ दिया रहता है, बट तुम उसमें ग्राफ से भी निकाल सकते हो. गॉट इट? अंकित निकला? कैसे निकालते हैं? 2 nautical miles means 2 nautical miles multiplied by 6000 feet. और यहाँ पे 1000 feet है. 0 0 0 0 0 0 12:1. That means for every 1 unit that you go down, you will go forward for 12. What does this also tell you? This tells you that you're producing 12 units of lift and 1 unit of drag. This also tells you for if you have lift of 12 units, you're producing 1 unit of thrust also. So this also tells you even for an A320, you're producing more lift than less thrust, 12 times more lift. Clear? Any doubts? No doubts? Pakka? Chalo. So now that you have understood L by D ratio, we will always try to go at L by D max. We will always glide at because it gives you L by D max. What does weight have to do with VMD? This is my favorite point. Piyush, Cessna 172 is an aircraft that glides 2 nautical miles per 1000 feet. A320 is also an aircraft which glides 2 nautical miles per 1,000 feet. My question is, you both are at 10,000 feet. And you're at a point A. And both of you fail engines. Who will go farther?
दोनों सेम ट्रेवल करेगा डिस्टेंस.
Ankit, what do you think? A320 और Cessna सेम जाएगा? एक 1,000 kgs का एयरक्राफ्ट, एक 72,000 kgs का एयरक्राफ्ट. अच्छा,
हाँ.
तो वो हायर स्पीड की वजह से ज्यादा आगे नहीं जाएगा. उसका हायर स्पीड है ना, वो ज्यादा आगे जाएगा.
बट उसका लिफ्ट और ड्रैग तो सेम ही है ना. आप जितना कितना लिफ्ट कितना वेट हो लिफ्ट बाय ड्रैग में आपने देखा कि कितना ही डाल लो आपको सेम डिस्टेंस ट्रैवल करेगा फॉर सेम हाइट.
करेक्ट, यू आर राइट. ठीक है, आई एग्री. पीयूष, योर आंसर इज राइट. आई एम टेलिंग यू योर आंसर इज राइट. Both of them will go and crash at the same place. But my question is, A320 तो higher speed पे है. That's well, Ankit is also right. A320 will be at a higher speed. But अगर वो higher speed पे तो ज़्यादा दूर नहीं जाएगा. बोलो नहीं जाएगा, नहीं जाएगा. तो सोचो क्यों नहीं जाएगा. What will be the difference? Higher speed will be the difference. And to main देख speed बढ़ी लेकिन decent angle same रहेगा, decent gradient same रहेगा. तो एक और चीज बढ़नी चाहिए, तब decent angle same रहेगा. Speed बढ़ी, absolutely correct. So the 320 will glide at a faster speed and a faster rate of descent because उसका VMD higher रहेगा. So the heavier aircraft will glide the same distance, but the glide speed will be higher. Is that clear? The difference between Cessna and 320 is A320 people will die first, Cessna people will die later. But they will always die at the same distance. They, you can make notes. Continue करता हूँ यार. So this is the diagram that I wanted to show you. An A320 and a Cessna, they will have the same descent angle. They will have the same distance that they'll travel, but they will cover. The A320 will basically die first because you just travel faster and everything. Yeah. Okay. Now let's see what does the headwind and the tailwind have to do. Farad, this is what you missed, huh? So pay close attention here. They're gonna tell you. We'll wait till his network stabilizes. Okay. Gone. Lucky खराब है इसका. How do you read, Farad?
ये पार्ट में डिस्कनेक्ट कैसे हो जाता हूँ मेरे को पता नहीं.
कोई बात नहीं. Luck खराब है. So let's talk about headwind or tailwind. Okay. So let's say you have headwind or you have tailwind, and how does it affect our aircraft's descent angle? Okay. I'll draw a diagram for you. You have a. Continuing on to headwinds and tailwinds. Farad, disconnect मत होइयो. अब मान लो आप एक सर्टेन रेट ऑफ डिसेंट के साथ डिसेंट करते हो. अगर आपका हेडविंड या टेलविंड आती है, so what happens really is your rate of descent or your rate of climb does not get affected. Your rate of descent or your rate of climb does not get affected. Is that thing clear to you? Okay. But what gets affected is, let's say you are going like this. आप जा ऐसे रहे थे. Now, this was your ground speed original and you were coming on to this angle. This was the angle that you were making. But when you have some headwind, this thing will come down. And your task will remain the same, but your ground speed will be lesser. So what will happen to your descent angle? Your descent angle will increase. Similarly, let's think about a climb. तुम्हारा पहले climb में अभी मान लो तुम यहाँ जा रहे हो और ये तुम क्लाइंब कर रहे हो। पहले तुम्हारी ग्राउंड स्पीड ज्यादा थी, या मान लो टेल विंड्स है, तुम्हारा क्लाइंब एंगल शैलो हो गया, हेडविंड्स आ गई, तुम्हारी ग्राउंड स्पीड कम हो गई, तुम्हारा क्लाइंब एंगल बढ़ गया। इज दैट क्लियर फराद? Okay, so the same applies to your climb wala funda. Now let's talk about configuration. Any change in any configuration will give you a steeper descent due to greater proportional increase in drag. Now what does this word mean? Have I taught you what does greater proportional increase in drag means? I think I've taught this to you. मैंने आपको पहले सिखाया हुआ है कि अगर आपका फ्लैप बढ़ता है तो L/D रेशियो कम क्यों होता है? बिकॉज लिफ्ट बढ़ती है, ड्रैग भी बढ़ती है, लेकिन ड्रैग प्रोपोर्शनली ज्यादा बढ़ती है। आई हैव टॉट यू दिस, राइट? So anything which reduces L/D ratio will give you a worse performance, because my glide performance is a direct reflection of my L/D ratio. Any doubts? Now, Piyush, let me show you how a landing is done. This is only for Piyush. Ankit, Farad, if you can understand it, good. Let's see how does a headwind or a tailwind affect our landings. Piyush, how do you land an aircraft? Tell me. You are 50 feet on the runway. You are here at 50 feet. How do you land the aircraft? Okay, you have come here till this point, you are in your approach phase. Anything that happens after 50 feet is a landing.
So when you're at 50 feet, you look out of the runway. You look ahead of the runway. See at the end of the runway, and
Okay.
you start pitching up
Point one, far end of the runway.
far end of the runway, and then you start pitching up until or unless, or you can say until or unless your power is died down and your aircraft landed.
So what you do is you basically break your descent. There are two parts to it. You break your descent and you fly parallel to the surface. Okay, when you fly parallel to the surface, this portion is known as rounding off. जब आप यहाँ पे होते हो, now you follow this path. When you follow this path, your speed is washing off, and you are at the same time you are increasing the nose attitude of the aircraft. You are increasing the nose attitude of the aircraft till the time you land. Okay, पीयूष, हेडविंड आती है तुम्हारा जहाज धम से गिरता है, टेलविंड आती है बटर लैंडिंग होती है, क्यों? हेडविंड आती है तो आप सोचते हो कि अच्छा होगा, लैंडिंग अच्छी होगी। यस, नहीं, हेडविंड से बस लैंडिंग डिस्टेंस कम होता है, हेडविंड से लैंडिंग अच्छी नहीं होती, हेडविंड से लैंडिंग घटिया होती है। What you did not mention is you cut power. Piyush, what instructors tell you? 50 feet cut power, look at far end of the runway, round off, check, sing check, sing check, sing check. This is how you land. Okay? Cut power, 50 feet, sure to make the runway, cut power. Now here the funda is, and when you cut power over here, your descent mechanics don't apply. Your glide mechanics apply. If you have a headwind, you will not come like this. You will come like this. And if you have a tailwind, you will not come like this. You will come like this after the glide. So because this angle is higher, this angle is lesser, the tailwind landing will always be a butter landing. Always remember this. A tailwind landing will always be a butter landing. So what can I do? Whenever you have a tailwind, instead of cutting the power over here, cut the power over here. Whenever you have headwinds, cut power late. This is what you're supposed to do. And cut power gradually. If you do this, your landings will always be the same. So you have to change the height at which you cut the power according to your winds. This is that one thing which is not taught in flying. In Indian flying school, especially. Okay. So we have spoken about what are the factors affecting a glide. Now let us see the factors affecting a emergency descent. Again, L/D ratio. Here we want to cruise at our highest speed, because at a higher speed my drag will also be higher, and my angle of descent and my rate of descent, all of them will be higher. So I want the L/D ratio to be such that it is less, so that my gliding angle is max. Okay, we need worst L by D ratio. So what we do, we increase the drag. Whenever we do an emergency descent, especially in the 320, I can tell you about 320. Our main aim is to increase drag as much as I can, reduce thrust. We want to increase the excess drag, right? So what we do is, once we establish in the descent, we take the speed breaks. ठीक है, वो लेवल ऊपर आ जाएंगे, लिफ्ट कम कर देंगे, ड्रैग ज्यादा बढ़ा देंगे, पैरासाइट ड्रैग बढ़ा देंगे. And we also want to extend the landing gear. Extending the landing gear will give us so much increase in drag you have no clue about. Okay, कोई doubt? No doubt. So now फराद भी अभी पूछ रहा है, यार ड्रैग ही तो बढ़ाना है भैया, मैं एक काम करता हूँ, मैं फ्लैप्स भी बढ़ा.
एक सेकंड वापस चला गया मैं.
Okay, so continue. So now फराद wants to tell us कि तो हम लोग फ्लैप्स भी ले लेते हैं, फ्लैप्स भी तो ड्रैग ज्यादा होता है, एल बाई डी रेशियो कम हो जाएगा. So हम लोग फ्लैप्स क्यों नहीं लेते? So yes, Farad is right. If we take flaps, our drag will increase and our descent angle will be steeper. But here our aim is not to have a steep descent angle. Our aim is to have a high rate of descent. And for a high rate of descent, we need a high steep angle, yes, but we also need high speed. If we extend flaps, our maximum speed will be limited by VFE. So I will descend at a sharper angle, but I will descend slow because I'm limited by VFE now. Or what I can do is I can not take flaps and I can descend like a rocket. Okay, so flaps is not extended due VFE limits. वेट बढ़ेगा यार, आरओडी बढ़ेगा. क्यों? स्पीड्स बढ़ेंगी. ठीक है, क्यों स्पीड बढ़ेगी? सेम फंडा. ठीक है, लेट्स टॉक अबाउट हेडविंड और टेलविंड. सो any forward or backward component of weight or whatever or wind whatever will not have any given effect. It will not have any given effect on our vertical speeds. So अगर मेरे पास headwind है, हमारे पास tailwind है, so what will happen? It will not affect our rate of climb or our rate of descent. ठीक है, what it will change is the angle and it will change the range. It will change the ground speed and the range, but the rate of descent is remain unaffected. Configuration, that means any extension of flaps, slats, or landing gears, it will increase the descent angle. Yes, but we don't extend flaps or lift augmentation devices because they will.
Increase
Limited.
lift also.
Perfect. Any doubts in descent? That is all about descent. After this, we will talk about turns. है एनर्जी? 3 घंटे हो चुके हैं ऑलमोस्ट. नहीं है ना? टर्न्स आज शाम को करते हैं 10 o'clock or 10:30. Okay, then we'll also do high speed flight. We'll call it a day now.